Hello, I'm Graham Lewis, and in this short video we're going to look at a tree diagram question that's about dependent events. So let's get started. So we've got this jar with 21 marbles on it. 12 are green and 9 are red. A person randomly picks a marble and then another without replacing the first. So let's draw a tree diagram to help us answer these two questions. So here what we've got is we can either get on the first one a green marble or we can get a red marble. On the second pick we could get a green marble or a red marble. If I got a red first, I could get a green marble or a red marble. Notice I've been consistent and that green's always going up and red's always going down. It doesn't matter, I could have done red up, but keep consistent. Now we need to put the probabilities on the branches. So we start off with 21 marbles, so I know that actually at the beginning, the probability of getting a green has to be out of 21, and the probability of getting red has to be out of 21. So now when we look at it, we've got 12 greens, and we've got 9 reds, and that's nice and simple. Now let's consider if we've got a green, what goes in here? Well, firstly, we're not replacing the first marble. So clearly we don't have 21 marbles anymore because we've taken a green out. So if we start with 12 greens and 9 reds, and I take a green out, which I have here, I'm left with 11 greens and 9 reds. So the probability of getting a green would be 11, one fewer greens out of 20. Reds, I haven't taken any reds out, so that's 9, but it's not out of 21 anymore, it's out of 20. Similarly, if I take a red out first, I started with 12 greens and 9 reds. If I take a red out first, I've now got 12 greens and 8 reds. So it's out of 20 still, but the numerators now are different. So the probability of a green, well, I've still got 12 of them because I've only taken a red out, so that would be a 12. But I've taken a red out, so I've got one fewer reds, and that's 8. So firstly, pause the video and just make sure you understand how the tree diagram works. Now I just want to look at this probability in a bit more detail, because this is the probability of getting a red given that my first marble was actually a green, and that is 9/20. So the probability of a red given a green is 9/20. Notice initially that the probability of a red was actually 9/21. So what's happening there, sorry I just made a little mistake there, what's happening there is the probability of a red given a green is different to the probability of a red. In other words, it mattered that I took a green first because my probability has changed from 9/21 initially to 9/20 if I take a green out first. Different answers. That means that obviously this is not independent. It matters what you took out first because you're not replacing it. So we call these not independent events. Some people call it dependent events. So just make sure you understand that and then we'll answer the question. So now we'll look at A. What's the probability of getting 2 red marbles? So look at your tree diagrams. I want a red and a red. So it's this branch here, which is red, red, that I want. So the probability of getting a red marble and a red marble, all you have to do is multiply the branches together. 9/21 times 8/20. And then you can get the answer. And I'll just pause the video and use the calculator to get that. And the answer there is 6/35. And I'll just use the calculator. Now let's have a look at the B, because this is quite an interesting one. I'm going to do it 2 different ways and show you that they're both the same way, and you decide which one you prefer. So what's the probability of getting at least 1 red marble? So green and green, so that's not included. Green and red, yep, that's at least a red marble. Red and green, yep, that's at least a red marble. And red, yep, that's at least a red marble. We've already worked that one out. We got 6/35, so we just have to work out the other 2. This one would be 9/21, so red first, and so multiply a green second, 12/20. So I need to work out that answer. And I'll just erase this here so I've got a bit more room. And this one would be 12/21 times 9/20. And we can work that out. Notice that the answers would actually be the same because 21 times 20, 21 times 20, 12 times 9, 9 times 12. So the answer to these two are going to be the same. So let's work that out. And I get 9/35, as you can see, both the same. So now, the probability of getting at least 1 red marble is this event, or this event, or this event. And remember in probability that when we have an or, we add them together. So we could have the probability of at least one red is the 9/35 added to the 9/35 added to the 6/35, coming to 18 plus 6 is 24/35, and we've got the answer. Okay, so there's one way of working out at least one red marble, but there is a better way. So obviously we are working out these three probabilities here and adding them up, but the probabilities, all of four probabilities, because there's only four possibilities, you can get a green and a green and a red and a green, or a red and a red. So all of these have to add up to 1, because all of the probabilities have to add to 1. So basically, because they all have to add to 1 and we're working out 3 of them, why not work out the one you don't want and subtract from 1 a little bit quicker? So in other words, we can work out this one here, 12/21 times 11/20, which comes to 11/35, and then subtract that from 1. You can see that all of these probabilities in the circles do add up to 1. 11 add 9 is 20, add another 9 is 29, add another 6 is 35, 35 out of 35 is 1. So you can see all of these four probabilities add to 1, but now we've worked this one out, so a different way of doing it, I'll just scroll right here, would be the probability of at least one red is actually the same as 1 minus the probability of green and green, which is no reds, which is 1 minus 11/35, giving me 24/35, which is a little bit quicker, I think, than working out the other ones. So don't forget, if you're ever asked to find the probability of at least one thing, then you can do 1 minus none of them happening, using that not or complement idea. Hope this video helps. Probabilities are great, subject and tree diagrams is great. Remember, to get the probabilities of each outcome, you multiply the branches together, and then if you have multiple outcomes, you may need to add or subtract whatever method you're doing. Good luck with your probability. Thank you.